Good evening, students. Today I will discuss the next part of the optics. So in the previous videos I have already completed spherical mirror, their reflection, all the characteristics of the images that will form. Next, for the refraction part, already what is refraction, what is the laws of refraction, all these things already has been discussed, right? So today I will continue from the next part. So in the previous video I have completed or ended my video up to the Snell's law, that is sin I by sin r equals to mu, and that mu is known as the refractive index. So now today I will discuss the absolute refractive index and relative refractive index. So in general, refractive index can be defined as the ratio of the velocity of light in the vacuum corresponding to the velocity of light in the medium. So when the refractive index is being calculated with respect to the velocity of light in the vacuum, that refractive index is known as the absolute refractive index. Later on, if if the refractive index is denoted as the velocity of light in one medium with respect to the velocity of light in the second medium, that refractive index is known as the relative refractive index. So let us see. So first thing is that relative refractive index. Absolute refractive index first. So absolute refractive index is basically velocity of light in vacuum by velocity of light in medium. If with respect to the vacuum medium is being calculated, then that part is known as the absolute refractive index. And if it is relative, then for relative purposes, in one medium, velocity of light in second medium. So if this is being discussed, that is one medium and second medium, then this is called the relative refractive index. Now the thing is that always this refractive index will be greater than 1. Why greater than 1? The reason behind is that for the absolute refractive index, velocity of light in vacuum with respect to the velocity of light in medium. So therefore always the velocity of light in vacuum will be more compared to any medium, right? So therefore refractive index or absolute refractive index is always be greater than 1. Okay, next thing is that this refractive index is unitless quantity as well as dimensionless, because it does not have any unit, whereas it is the ratio of the same physical quantity, that is the velocity. Okay, so the next coming that on which factors this refractive index depends on. The factors that affects this refractive index is basically, first is that the nature of the medium. Nature of medium. So the thing is that if the medium is denser, then the velocity will be less, and if the medium is less density, then the velocity will be higher. So therefore, according to that, refractive index will be affected. Next is that color of the light. Why color of the light? Basically, we know that velocity equals to n lambda. N is the frequency, lambda is the wavelength. So these wavelength basically depends on this color. So therefore, as wavelength depends on color, therefore and wavelength depends on the velocity. So according to the color, the velocity will change. Therefore, on the color, the refractive index is depending. Next is that the temperature. If the density of a medium decreases with increase in temperature, so therefore speed also increases with the increase in temperature, and consequently the refractive index will be decreasing, right? So third is basically the temperature. It is that third factor on which the refractive index of a medium will depend. Next, coming the discussion according to the wave theory of light. So according to the wave theory of light, 1 mu 2. What is this notation? This is the notation that the velocity of light in medium 1 in 1, velocity of light in 2. Now, if I write 2 mu 1, so these notation define that is 2 by 1 medium, velocity of light in medium 2 corresponding to medium 1. So if I write it like this, according to the wave theory, we can write 1 mu 2, that is nothing but 1 by 2 mu 1. So this is the basic relationship between the two medium from which one light is moving from one medium to the another. Now this thing is basically that part, that is 1 mu 2 equals to 1 by 2 mu 1. This part is basically giving you the concept of the relative refractive index. Okay, hopefully it is clear to all. Next, coming for the part, that is from this part you will face basically some numericals. That is, suppose the refractive index has been given and the velocity of one medium is given. You need to find out the refractive index or velocity of the next medium. Suppose I am giving you a numerical. Suppose for a particular medium, refractive index is 1.5 and velocity of the first speed of the light is given as 3 into 10 to the power 8 meter. So find the velocity of light in the second medium. It is in the vacuum and in the second medium. So we all know that mu equals to velocity of light in the vacuum corresponding to the next medium. So you need to find this v. Mu is already given, so it will be 3 into 10 to the power 8, 1.5. That is the basic calculation. So this point will be there, 110 will be applied, 3. So the velocity will be 2 into 10 to the power 8 meter. So this kind of numerical you may face in your examination. I think up to this it is clear to all. In the next video I will continue with the refraction through the glass slab and the prism. Okay, thank you.